and then there's sort of an order that's inherent when you gather these things together. So what the composite does is the composite just gathers together all of the actions and then calculates what's happening in that system. So then it goes from left to right. So first it sees that it wants to move the particles, and then it's going to emit them. Add a little bit of wind friction. There's your initial velocity. And then after all that, it checks to see the age of the particle and whether it should die or not, because here we're saying that particles can only live to an age of 40 and then they're going to die. So unfortunately, sometimes you have to kill them. Yeah, so there's a couple of ways of making particles disappear. One is to kill them based on how old they are. So in this case, when they're 40 frames old, they're going to die. The other way is to define a region in which they exist, in which case, once they leave the region, they no longer exist. So, you know, that's what the composite does. It gathers things together. Now, what the baker does is the baker actually does or calculates the simulation. So, inside your baker, you'll see some things like number of pre-roll frames. This is how many frames you want to have happen before it starts. So if I put this down to 0, for example, my first frames are being created on frame 1. So there's no pre-roll, there's nothing happening before frame 1. So I see the fire just starting to build up there. But if I put a certain number of pre-roll frames on, I think it was up to 20 before, let's put it to 30 just in case, it means that the system starts before frame 1 of your timeline. So it has a chance to reach a stable kind of system quality there. And then sometimes you also want to set a maximum number of particles. Let's say, for example, if you didn't kill them, then they would just keep adding particles in every frame. The emitter creates particles, and so it creates particles in every frame. And if you keep creating and creating and creating, eventually you'd have an infinite number of particles, or you'd have so many particles that, you know, your machine would crash. But obviously, with the 64-bit version of Harmony, it's very difficult to make it crash. But theoretically, if you had a huge number of particles, then you could slow your system down to a crawl, or you could just, you know, it could take a very long time to render. And if those particles aren't, you know, being seen or being used, or if there's, you know, it's good to have a limit. So the limit by default here is set to 10,000. And then there is also the ability to move the particles in here, and the difference between having a move in the baker and having the move up here is that if the move is up here, it's happening before it calculates all the other stuff, whereas if you put the move down here, it's happening after. So remember I mentioned earlier that you could have a region that defines where particles exist and they can leave that region. If you put the move here, it's going to move them first and then calculate if they've left the region. If you have the move only in the baker, then it's going to first see whether it's left the system and then going to move it. So then if you are using a sync, that's what we call it, to do that, then sometimes you might see particles outside your sync if you're only using the particle baker to move your particles. But we call this an inherent move. So in other words, it's a move that's kind of outside of the particle system. And then down here you've got your visualizer. And what the visualizer does is the visualizer allows you to define where that particle system is defined in space for the compositing of our elements in here. So let's take a look, for example, at my perspective view here. Because these particle systems are inherently 3D systems. They exist in 3D space. So just like I can just rotate around my perspective view, and you can see that the particles really are in a 3D space. They're created inside a 3D region, and so they're existing there in a 3D space. But even though they exist in a 3D space, before we render the entire scene, we flatten them down to a plane. And the reason that we do this is to make the system a lot more efficient, and so that it, you know, renders out without having to take 5 gazillion years to render everything out. And so since most of the time you're working in either 2D systems in 3D space or you know, parallel to your camera, then this works out just fine. But when you're flattening a 3D thing down to a 2D plane, then you kind of need to define where in 3D space that plane exists. So you'll see that there's 2 peg inputs in my visualizer. There's one on the very left, and the one on the very left already has a peg in it right now. And this peg on the left defines where the overall position, rotation of scale of the system is. So in other words, if I take my peg here and I move this peg, it's moving, whoops, sorry, my computer just slowed down a little bit there. So if you move that peg, then it's moving the entire system in space. If I add a peg on this side, and I'll turn it on Enable 3D just to make it easier to look at. So if I add that peg on this side and I move it, do you see that it's not actually moving the system? What it's doing is it's moving where the plane that it flattens down to exists in 3D space. So when this fire is flattened down to a 3D plane, if there are other 2D or 3D objects in my scene, I can move it into position forward and backwards with this one without changing the size of the object or of the system. So that's pretty much what I wanted to talk about for the first intro to particles, just to break apart the main topics. So you've got your regions, you've got your particle composite, and then you've got the baker and the visualizer. And these three elements plus your emitter are you know, the things that you need to have a particle system. If you don't have a visualizer, baker, composite, and emitter, you don't have a particle system. But these other ones are all optional. These other actions are all optional, so you can play around with those. So what I'd like to do next week is I just want to break down some of the properties of the emitter in more detail, because the emitter can be a little bit confusing at first, because there's a lot of interesting and useful parameters inside there that you can adjust. So I'll see you guys next week. Take care.